One more thing to talk about, that's going to be kind of the big picture of what's going on when we are actually calling uh, to compile a program. And a program is going to have multiple VM files. We're going to have all these different classes we write in our high-level Jack language. Those are all going to be one folder. We then want to compile that folder together. If you've ever done anything in C, this is like when you compile, you want to compile all different C files and link those together. In Python, that might be, you want to make sure you have your import set up so you can then kind of get all that together. We don't really compile Python, but still, same idea. We want to get all this stuff together so we can run it and have it all work. So we may have a directory, and we're going to have two Jack files. That's our high-level language, foo.jack and then bar.jack. The standard is going to be that if you have a file named foo.jack, within that you'd have a single class called class foo, the name of the file. And in that, you would have a main. So somewhere there has to be a main that we want to run. So likewise, we also have a bar.jack file, which has a class bar, and it has its own constructors, methods, properties, all of that stuff. And when we compile this, we want to compile those together so it's a single ASM file that runs. So directory, single ASM file. So what's going to happen is that when we compile this, starting in project 10 and 11, we're going to take that directory of Jack files and compile them into a set of VM files. And those are going to have things like foo.main, foo.blah, bar.new, bar.blah, whatever. Name of the file, function name. All right, so we'll call Jack compiler on the directory name, and then that will generate those files. And then we're going to call our VM translator on this directory, and that's what we're doing in this project. And that's going to generate a single ASM file which has all of these functions. So you can just use the function name in the VM file for your labels. That makes it a little bit easier. When we boot, we haven't really dealt with this yet. In Project 7, we had test files that would set up the stack pointer and some other segments, and we didn't have to worry about anything. But when we now boot in a program in assembly, when we're writing a full compiler, we do have some expectations. We need to handle some things and get everything ready to run. So we're going to have one file in a VM program. It's expected to be called main.vm, and one function in this file is expected to be called main. So we have a main.main, and we want to run that. The convention we're going to use when we set up everything is that the stack is going to start at address 256. And then every time we push this stack, it's going to increase above that. So when we run a program, we need to initialize our stack so it's ready to be run. And then whenever the VM starts running or reset, what we're going to do is start an argument function called sys.init. And that is going to be designed to call main.main and then enter an infinite loop. So in case main ever returns, this we could then be in a loop. So to boot, that means we need to set our stack pointer equal to 256. We call sys.init, and that's it. That's how we boot a program. What that means when you're writing this is that if you are writing a full program that includes writing the boot code, then the first items in your assembly file, which will be put at address 0 in the instruction memory, needs to be set your stack pointer 256, all sys.init. However you want to do that, you can make use of functions you have to call something, or you can just simply write your own code, hit those instructions to jump to that program. All sys.init, sys.init will call main.main, and we are fine. That kind of handles everything. So that's your boot code. Then this is finally the last item related to that, the standard mapping. If we have our hack RAM on the computer, we have our segment pointers, the temp segment, general purpose registers, static variables in stack, and the way those are going to be mapped for the VM, we have the pointers and registers up to 0 to 15. Static variables can go up from 16 up to the beginning of our stack at address 256. We're then going to have what's called the heap. And this is where you can store objects and data. Those will all be stored in the heap. So this and that will always be pointing to stuff up there in the heap. That's just sort of memory we can use to keep track of stuff. We have our memory mapped I/O, which in our case is the screen and the keyboard, and we also have just unused memory. That's kind of what we're going for. Okay. Yeah, well, don't worry about that. I will say when we start compiling things in the Project 8 test, we will be passing a separate command line argument. So we'll say Python, the name of our VM translator. So we have Python VM translator argument 0, argument 1, or sorry, yeah, whatever the name of the Python file is, argument 0. Argument 1 is going to be the name of the directory we want to compile. Then we're going to have a separate flag over here, and it's going to be -y or -n. -y would mean emit the boot code, which is set your stack pointer to 256, call sys.init. -n would be do not do that, just like in Project 7, just emit the code. And if you do that, the autograder will work. And if you don't do that, if you automatically submit the boot code, I think as long as you get the later stage 2 files, that means it's working. It's not that big of a deal, but that's how it is currently set up. All right, and that's booting. The idea is that you have one single code writer object. And the first time you initialize that, you write your initial boot code, stack pointer set equal to 256, call sys.init. And after that, you just take each VM file in the directory, assemble it line by line, and just kind of keep appending that to the bottom of the file. And then it should work, as long as you take the function name of the VM, wrap it in your in parentheses, then when you say call main.main, it will be somewhere in your assembly code. The assembler, when it assembles this into the hack language, will take care of that for you. All right, let me know how I can help.